All right, here we go. Let's get started right away so we can get ready for our Unit 4 test tomorrow. That was my intro. Let's do this. Here we go.
You gotta keep it consistent with your handwriting.
I have 102 subscribers.
Oh, you might lose two.
Oh my goodness. Yeah, right?
Yeah.
Right?
How many do you have? Watch me subscribe.
Ouch. Which two events are most likely to be independent? That is true.
They don't have to, like,
They don't affect each other.
Right? There is no relationship between them. Right? When I look at the others, flat tire, being late for school, there's a relationship there. If you're driving in the car to get to school, that's going to affect when you get there. Getting an A in math, getting an A in physics, you need math to do physics. So probably going to have a relationship there. Car accident, and like today, there was lots of rain today, so probably more car accidents on the road this morning. Hopefully not you. And then being a senior at a school and driving to school, being a senior means you're old enough usually to have a license, so you're more likely to be driving to school. So the only two that are most likely to be independent. Again, am I saying that these are independent? I'm not. I'm just saying these are the most likely to be independent. Question on number 1. Number 2. Caesar, do you mind reading this for us? Thanks.
What final is the probability that Hillary Clinton will run for president in 2020? As a Democratic candidate, 45%, and the probability that John
Kasich.
will run as the Republican candidate is 20%. If the political decisions are independent, then what is the probability that Hillary runs for president?
Excellent. So we've got a couple of things here. We have the probability that Hillary Clinton runs for president is 45%. So 0.45. The probability that John Kasich runs as a Republican is 0.2. And they want us to find out what? What are they asking us to find? But not just that Hillary runs, but that it's not Kasich as a Republican, someone else. All right, so this is a little confusing question. You definitely want to be paying attention here. So the first thing I'm actually going to figure out is, what is the likelihood that they both run for president? That's the and. And what word, or excuse me, the word is and. What operation should you do with and? Those are 2 incorrect answers. That's the only other incorrect one. Multiply. Very good. And is multiply. And means multiply. Now, I'm allowed to do this because it says something in this problem about these 2 events, that they're independent right here. If their political decisions are independent, that means it's saying, hey, by the way, if you want to multiply these, all good, they're independent. All right, so let's multiply. What is 0.45 times 0.2? I think it's 0.09, right? Try it again. 0.45 times 0.2. Now, what is that saying? There's a 9% chance that both will run. All right, but I want to know what? Only Hillary runs. So here's Hillary's number, 40%. But most students say that's the answer. But there's a chance that if Hillary runs in that 45%, there's a chance that Kasich also is running. That's the 0.09 that we have to subtract out. Very good. So I'm going to write down 0.45 minus 0.09. Because basically we're saying, this is what's confusing, so really listen to the words that I'm saying. Listen to the words that are coming out of my mouth. Okay, I'll speak slower. In this 45%, there is a chance that on the other side of the ticket, the Republican side, Kasich is the nominee. Okay? So we have to take that out to get just Hillary and not Kasich as the Republican. So that's the probability that they're both running, that 9%, that I subtract out. So the answer is just 36%. Any questions? That's a confusing one. All right, that's unfamiliar to most students. And again, as Lily mentioned, that question was gone over in December, so it's been at least a month. Let's try number 3. Can we try number 3? Let's go number 3. Ooh, Diana, try this one. Oh, Diana's going to do number 3. Thank you, though, Papa. You'll get another one. Yeah, I mean, in New York. Ithaca, New York. It's a city.
Found that 30 had visited the Museum of the Earth and that 80 had been to Home Depot. So out of 120, 30 are and then 80 Home Depot. Well, you're not gonna write that.
Well, at first, no one laughs when I write questions like these.
Why?
I was just like, the Museum of the Earth and Home Depot. Like, does Home Depot maybe do something with Earth? Like building something? No? Thought it was funny. I enjoy writing the questions. There you go. Very good, Dino. Okay. So, key thing in here again is that it says they are what?
120.
No, is that they are, if it appeared that going to these two places were independent, then it shouldn't matter whether you told me that you've been to one or the other. My probabilities of you having gone to each will be the same. So what I do personally is I first focus on the margins. So I picked this margin here. You see that margin? That margin does not take into account what? What does that margin not take? No, it takes into account that they went where? That they went to the Home Depot. Does it have anything to do with whether they went to the Museum of the Earth? No. So if it's telling me that they're independent, to find out this area here where it says question mark, what's that number? I ask myself, what is 80 out of 120? So 2/3? That should be the same proportion for I don't know out of how many people went to the Museum of the Earth. 30. So guys, we're just setting up a proportion. So what's that number? What's that question mark have to be 2/3, 0.67? Sure, you can do that. Or you can just do a little bit of math here. How do you get from 120 to 30? Divide by 4, so 80 divided by 4 is 20. I'm looking at the factor to get from there. You divide by 4 if they're equal. Pick a margin, either margin. Sure, you're doing it the other way? Let's do it the other way. Yeah. From the table. That's a 30. It's hard to see. Oh, I'm just setting, if I have 80 out of 20, and these are independent events, then when I look at the same fraction here, it should be the same ratio of 2/3. Can I show you the other way for Dino, and then maybe that'll help click it? So the other way you could do is 30 out of 120. If you did 30 out of 120, yes? So then the other fraction, bless you, I would put is question mark out of 80.
Oh my goodness.
Now this one's not as easy to see because there's not a whole number factor here, right? You have to divide by, I think what is that? 0.75 maybe? Whatever the number is, but you could find the same thing. If you want to do the quick mental math, what's 80 times 30? 2,400 equals 120 times question mark. And then 2,400 divided by 120 is 20.
What chapter is that from?
Ooh, probably 15. It was before the break. Okay, so I don't care which margin you pick. Select a margin, write a fraction, and then write an equal fraction and set a proportion up. and solve for your unknown. All right, let's do number 4. Let's see. Pablo, why don't you read number 4 for us? Okay, so let's just ask the question. What would satisfy saying that both chair people are the same gender? What would you write? No, I'm not even talking about numbers yet. Just like, what would the people selected need to be the same gender? You're like thinking too hard. Like the first person I pick is a man. That means the second person has to be a man if they're the same gender. So we have Pablo got to be man first, right? Jeez, Pablo. So if that's one way to satisfy it, what's the other way? Woman and woman. So what my brain thinks is if I find each of these probabilities and add them together, that will give me the probability that the chair people are the same gender. I'm just trying to map out the thinking here. That's it. I'm not worried about the math yet, because tomorrow, the most important thing is to understand what the question is asking you to do. Obviously, the math is important, but if you don't know what it's asking you to do, then who cares what you do with the numbers? Bashir. So it wants to know, let's just say the question was, what is the probability that they're both men? Okay, so we find that. Then it said, what's the probability that they're both women? You can find that. So when it says, what's the probability that they're both the same gender? You find men and women, and then you put them together. Like, what's the probability that the people in this class are over 18 years old? Is that a number? Yes. Okay. What's the probability that the students in this class have a driver's license? Yes. So good. What's the likelihood that I pick someone and they have a driver's license or they're over 18? You add them together. So you take each one and put them together. Or and are different. Okay. Or is addition, and is multiplication. So this is an or and an at the same time, which is crazy. We need to do individual ands. See how I wrote and there? And then I'm going to put them together. Oops, sorry. I'm going to put them together with adding. Go away. Thank you. With adding. Because both of these satisfy the question. Both men and both women satisfy the question of the same gender. So it's an or. So they're either both men or they're both women. It's kind of, I know it's kind of like all, that's difficult because it is an and an or in the same question. So let's do the men. How many total council people are there? There are 9. When I pick my first man, how many men are there out of 9? 6. So I write 6 over 9. Now, once that person is selected, what happens to the total number of city council people? It goes down to what? 8. And since I just selected a man, and I'm asking now what's the likelihood that I select another man, Lexi's got it, that should go down too. And you know what operation I'm going to use for the word and? I'm going to write multiplication for and. This is not a cross multiply. That was on the last problem when we solved the proportion. This is multiplication of fractions, which is just straight across multiply. So it'd be 30 over 72. I'm going to pause here. Questions? And is multiplication or is addition. Just think of your favorite time of the day, the AM. Well, if it multiplies like, are you talking about straight across? That's how it should multiply. It might reduce it. Yeah, that's reduced. Okay, let's do the women. when I pick the first woman, how many total women how many total city council people are there? 9. How many women are there? 3. Very good, because when I pick the second woman, I've already selected one woman, so there's one less city council person, and there's one less woman. So that's going to be 6 over 72. So what's 30 over 72 plus 6 over 72? You got it. 36 over 72, which is, if you look at that, 1/2. My answer selections did not show up, but I believe it is B for 1/2. So I added those. Once I did them, I added them. Is that confusing to put that there? Probably, sorry. You're good, Pablo. When you have your thought, ask it. Please ask if you're like, whoa, what happened? How did you get 36 over 72? This is what you need to ask. So 1/2 is the answer, because 36 over 72 is half. So there's a 50% chance that the 2 chair people are elected or chosen will be of the same gender.
That's crazy.
That's called probability. Well, if I had to look at each of those added to get 50%, right, this is 30 out of 72, and this is 6 out of 72. So it's much more likely that it'll be the 2 men. But when you put them together, that masks that. So you might be thinking, oh, that's crazy, but it's still more likely to be men because there are, 2/3 men. Yes, Charlotte.
I just saw one of that. I did 3 over 6, 6,
So that's just using operations that you know with the numbers in the problem. That will get you into a lot of trouble, especially on the SAT.
SAT?
Any standardized test you do, a lot of the answer choices that are wrong, they'll just take the numbers in the problem and do a bunch of operations with them to get students to pick it. So I would definitely don't do that. All right, that's just a coincidence that it reduced to the same numbers.
What if I do 36 is a half, right? And that's the answer with those each other because they're 2 low.
Well, because that's not the problem, right? That's just taking the 2 numbers and doing an operation. It's all good. Let's go to number 5. You're good. I see the words geometric model. What do you think of when you hear geometric model? Waiting, and more specifically, waiting until the first success. So when you look at these answer choices, which one is waiting until the first success?
B.
B. The most common wrong answer I see is letter C, because letter C says until, and people focus on that word until, which is the word to focus on, but that says until you find 3 bad mufflers, not 1. It's waiting until the first success. Okay, so keep that in mind for tomorrow. No. Number 6. It's the same number, it's the same answer choices, but now it says binomial model. Not until, it's number of successes out of a number of trials. Pablo. Until is geometric. The reason until didn't work for letter C is because it said until 3 bad mufflers. If it had said until 1, like your first bad muffler, then that would have been geometric. It's until the first success. Waiting until the first success. Letter B is right because you're waiting for the first success. It's waiting until the total of 3 successes. And that's not geometric. Okay, so which one is number of successes out of a certain number of trials? It looks like it's D, right? Total number of Democrats among a group of 20 randomly chosen adults. Why is it not A? The number of cards of each suit in a 10-card hand. There are that's it could be 1, 2, 4. That's okay. Remember, it needs to be a constant probability of success, and it has to be success and failure only. How many suits are there? There are 4 suits, not 2 suits. Okay, so keep that in mind. Just success and failure. Number 7. Binomial means a number of successes out of a certain number of trials. Number 7. Read this one for us, Gilberto.
An ice cream stand reports that 12% of the cones they sell are jumbo size. We want to see what a jumbo size cone looks like. So we stand and watch the sales for a while. What is the probability that the first jumbo cone is the fourth cone? You see the huge seeds and stuff.
You guys do this, right, on Saturdays in the summertime? You just go to an ice cream stand and just watch and see? No? There's still snow cone stands. I go to some snow cone stands. So imagine snow cone stands. I'm sorry? What's that? Oh, like the person that's on the little like cart? Gotcha. Okay. So, what? I'm sorry? So Pablo's brain says binomial. Why, Pablo? Okay. Jonathan? Okay, so then if you give me a different explanation, why is it geometric?
Because it's it's probably the first jumbo.
That is the question, but why is that geometric? Okay, Dina?
Waiting, because if you wait until the fourth one,
To get your,
success.
very good, so that's why it's geometric. You're waiting until the 4th cone to get your first success or jumbo cone. Okay, so it's going to be the probability that the first success happens when? On the 4th one. So that means it's failure, 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 success. All right, so what is the probability of getting a not jumbo cone?
0.88.
0.88. How'd you get that, Lily?
Subtract 0.12.
From 1. Right? If you haven't changed it to a percent, then you would subtract it from 100. Sorry. If you haven't changed it from a percent to a decimal, it would be subtracted from 100. But you actually changed it already, so it would be from 1. All right, so that's what you get 0.88. How many failures are there? How many not jumbos? 3 times our jumbo of 0.12. That's all you have to do. Type it in the calculator, and you'll get your answer. So it's 8%.
Wait, where'd you get? 188?
Lily, where'd you get 0.88?
88, subtract 0.12 from 1.
Because remember, there's only success and failure. So if 12% is our success, then failure, the opposite of that, the complement would be subtracted from 100 if you're using percentages. And I'm going to recommend using decimals, so subtract it from 1. Now, number 8 is similar, but it's phrased a little different with the question. What is the probability there is exactly 1 jumbo in the first 6 cones sold?
That's binomial.
This is binomial. This is exact number of successes, 1, in a certain number of trials, 6.
Does this have to include like a combination?
It does. That's why you have your calculators with you. And tomorrow you'll have the calculators as well. I did post a formula sheet to Google Classroom, and you will get a formula sheet during the test. So if you want to see what you're getting, it's on Classroom. All right, so I'm going to write down binomial. And the probability that our number of successes is how many? No. 1. Exactly 1. I know it's a little different than weighting. But now this is when you write the number of successes equals how many total trials? 6. And we're choosing how many to be successes? Just 1. So what you notice right there is I wrote 6, choose 1. That's the notation for a combination. That's the notation for a combination where you have 6 choices and one of them is going to be a success. So it could be your first one, your second one, your third one, your fourth one, your fifth one, or your 6th one could be your success. Okay, now you can do on the formula sheet, I give you the formula with factorials, but what would I recommend doing? Use the calculator to type 6, and then PRB, number 2, and then 1. It gives you 6 because there are 6 ways to order that one success. It can go in any of the slots. Times. Now it's up to you when you want to, what you want to do here. I put the successes next. So how many successes are there?
1.
All right, so I just have 0.12. Now if I had more successes, I'd have that squared or cubed or whatever it is.
Is that a subtract?
That's times.
Oh, okay.
And then times. How many failures are there?
0.3. Oh, 5.
There are 5. There are 5. So to the 5th power. So if you do all that, you should get your answer. What most students forget to do, they forget, they forget the combination. Okay, most students forget to do that. So don't forget the combination. So what happens when you get it?
You get 1.799.
So I think that rounds to 38%. Excellent. And Shiloh's right. This is not exactly the same, but pretty much the same. I think I changed it to drinks in the Kahoot.
The 5 is because of the fails, right?
5 failures and 1 success. So if it had said, what is the probability that exactly 3 jumbos are among the first 6, this becomes 6 choose 3, 0.12 to the 3rd power, 0.88 to the 3rd power. Because remember, these have to add up 5 and 1 have to give you that total number of trials.
And you didn't put 1 on 12.
You can.
You don't have to.
It doesn't matter. I'll put it there for you. 1 success, yeah. But if it's not 1, yes, you should have something there. Yep. Okay, number 9. Ooh, I like this one. Jimena, can you read number 9 for us?
The creditor's plans to cost a fair coin 200 times. He wants the first 20 tosses and also finds that she got 15 heads. But then he gets bored and leaves. How many heads do you expect her to have when she has finished all 200 tosses?
I just imagine this is what you guys do when your cell phones and the internet, all of that comes crumbling down. All right? All your cell phones are dead. Your internet's gone. So we got to flip a coin to have some fun. Exactly. The apocalypse. The zombies. Yeah.
It's a trick question because
Ooh, is it a trick question? No. Students think it's a trick question, but it's not.
there's only 2 like options. So
Ooh, there's 2 options? There's actually 5 options.
wait, it's a head and tail.
I'm just messing with you again. I meant like there's 5 choices.
Yeah, it's like heads and tails.
So let's make sense of this, right? Let's make heads or tails of this.
It's 50.
Sense, like CENTS? I'm on fire, but no one is enjoying this right now. So let's just start with, somebody has to appreciate it. I'm appreciating it. All my subscribers are, minus you.
Appreciated it.
Let's start with how many flips you watched. How many flips did you watch your friend do? 20. So 20 flips.
Surprised I made it to 20.
How many heads did your friend get? 15 out of 20. Now, you don't see your friend do how many remaining flips?
180.
Very good. So Pablo's brain saw 200 total. We saw 20. So take away, you get 180 left. So 180 flips remain. If you don't know what the results were, Dino just told us it's only 2 options, heads or tails. And what do you know is the likelihood of flipping a coin and getting heads or tails?
50.
It's 50-50. So if I had to tell you, if I didn't tell you, but you had to guess how many were heads, what would you put here?
Half.
No, you'd put 90.
That's not an option.
Because that's half of 180. So you saw 15. You think he or she is going to flip 90 more heads. What's 90 plus 15? 105.
Wait, I think you said we can do like.
Plus the 15.
Are we gonna like put just 50-50 because sometimes it's more than 15, sometimes it's less than 50.
That's what happened when you saw he or she flip the 20 total flips and got 15 heads, right? That was more heads than you thought, right? Because you thought it'd be 10 heads. But we're not here for these. So what do I think is going to happen? Half. What do you think students think is going to happen? They put what here instead of 90? No. They put less. They think, oh, well, the coin's got to even out to give you 100 total. Right? Oh, you've got more heads earlier. So that means it's got to even out going forward. Is that how a coin works? The coin doesn't know what it's doing. All right? This is something that I've talked about a lot called the law of large numbers. I mean, no. I mean, it says expect. It's not really an expected value. It's just how many heads do you expect her to have at the end.
Hopefully just one time.
Okay. Please don't. Let's go number 10. Let's do number 10 real fast. Then we'll move to the free response. What? I don't know if we're going to. We got to do the free response. It's much longer. Physical fitness test. Yes. I don't even know. They used to have national ones. I don't know. Do they do that anymore? National physical fitness tests? No? Okay. Cool.
You know the little patient test they're using about
Ah.
the patient test.
Do you know what that is?
The standard deviation of the combined scores of push-ups and sit-ups. Now, this is number one, 100%, going to be only missed for one reason, because students forget how to do this problem. And Natalie is right. It's push-ups and sit-ups. Put up or shut up. Oh! Oh my gosh, I'm sorry, listeners. Please excuse me. I meant push-ups and sit-ups. You must think, and Natalie said this up here, quiet enough for her to hear, but not for everyone else to hear, variances.
Your tattoo.
That's right.
How could I forget?
So, the standard deviation for push-ups is 4. Why am I squaring it? Because I need to actually work with variance. Variance is standard deviation squared. Okay? The next one says 11. But I'm going to square it. So what is 4 squared plus 11 squared? 137, which is an answer choice. And why do you think I put that as an answer choice? To trick you. Because this is squared ups. Squared ups.
Just like the math thing.
This is the variance.
I know,
I'm not sure what you're trying to say. So the standard deviation is the square root of that number, which is 11.7.
Yeah.
You have the little arrows, the little arrows.
Yeah, above the enter. Hit the above the enter key. All right.
Free response.
Here we go. Free response. We got to move fast. Here we go. Got to move fast. Okay. Let's move fast. Okay. I got a couple of things happening in this problem. I have the probability that I get an A in English, which is what? 0.2. Probability to get an A in physics, 0.1. Sad. And the probability that I get an A in both, so English and physics, 0.05. Man, not looking good for me in getting A's in those classes. Jeez, I wish I would have studied more. Now, letter A says, what's the likelihood that you don't get an A in either? And my brain, when I see you do not get an A in either, I think the complement of that, is that you get it in either.
neither.
So this is neither. Do not get an A in either is neither. So the complement of that would be either. So either or.
So 0.2 is 0.1?
So I've highlighted this. You don't get an A in either. So the complement is you get an A in either. I should probably make that more clear. How about that? Get an A in either. And either is just another word for or. Very good, Giuseppe. Now, there's a formula to find the probability that an event occurs or another event occurs. And I posted it to Google Classroom. All right, the formula is you find the probability of the first event plus the probability of the second event, but you subtract out, what do you subtract out? Very good.
Which we already had.
Which we have all of this. Magical.
And then
So what is the probability that I get an A in English
0.3.
or physics? Also,
0.3 minus 0.05.
which is 0.25. That's
And
right.
then don't you subtract the 1 minus 0.25?
Well, yeah, I'm not done.
Oh.
So we have 0.2 plus 0.1 minus 0.05, which equals 0.25. So most students stop there
No.
and they say it's 25%. But that is the chance that you'll get an A in either. And we don't want the likelihood you get an A in either. We want the likelihood that you get an A in neither, which is 0.75. So the answer is 1 minus 0.25. Charlotte. Okay, great.
Wait, you had to subtract it?
The reason I subtracted it from 1 is because I was trying to find the complement. I found the complement, which is 0.25 of what I want. So then I took that away from 1 to find what I actually want, which is the probability that you get an A in neither English or physics. Okay, yeah, Pablo.
Complement is the opposite of what
The opposite, yes. Ooh, this is a good word here. Are earning an A in each class disjoint events?
Wait, application, every time you like A, is it most likely you're going to use the complement?
Yeah, whenever I see neither, I'm thinking complement. Yes, I mean, do not get an A in either is neither. So yeah. What does disjoint mean? Who remembers disjoint? We haven't used that word in like a month. Yeah, Diana?
I would say that they're independent.
Now that'd be independent.
One of them depends on the other half.
That would be dependent. Jimena? Jimena? Hold on, Jimena?
They can happen at the same time.
Perfect. Nice job, Jimena. Disjoint means if one happens, the other doesn't or can't. I'll repeat that, and it might be important enough to write down if you haven't written this down. Disjoint events cannot happen at the same time. So, if we understand that if one event happens and the other can't to be disjoint, are these events disjoint?
No.
The answer is no, they're not. Why not?
Because you can earn an A in English and physics.
Very good. And if you want to, that is totally acceptable and done. You're right. Move on. You could also say, I have a 5% chance of earning an A in both. But what Lexi just said is perfect. She said, because you can earn an A in physics and you can earn an A in English. So they're not disjoint. So even though I'm writing not disjoint right now, on the test tomorrow, what are you going to write?
No, because there's
A sentence. Thank you. That's good. Yep. Great.
Oh.
A sentence. A sentence.
Wait, what would the actual answer be?
What Lexi just said. She said they're not disjoint because you can get an A in English and in physics.
Oh. And
And disjoint means if you get an A in one, can't get an A in the other. Now that would be true if we were talking about one class, right? Just English class, A, B, C, D, and F are disjoint. Once you get one grade, you can't get any of the others. The last one. Are they independent? Ooh.
No.
Are they independent? Before I answer yes or no, you know as a statistics teacher, I'm going to do some math. All right? So it's been a long time, but you should brush up on this. For independence, it means the probability of A is equal to the probability of A given B. Oh, man. Is that going to come up tomorrow? Yes. What up, formula? All right. So I asked students to pick one. Do you want to pick English or physics? I don't care. I heard physics louder, so I'm going to go physics. What's the likelihood that I get an A in physics? What is it? 0.1. What is the likelihood that I get an A in physics given that I already have an A in English? And a lot of students write what number here? 0.05, which is wrong. Because this is not what is the likelihood that you get an A in both. It's what's the likelihood that you get an A in physics, given you already know you got your A in English. So the formula that's on the formula sheet says to take your denominator and put your probability of getting an A in English. And the numerator is the probability of getting an A in physics and English. That one is 0.05 in the numerator. What is in the denominator? 0.2. What is? Say it again. No, this is probability. So what is 0.05 divided by 0.2? What is it? 0.25. So I'm going to circle these numbers, and I want you to look at those two numbers. Because they're not. Oh, like letter A?
Yeah.
Well, letter A is asking a completely different question. That says, do not get an A in either English or physics. That A has no, do you remember what it's called when I say given? You know what kind of probability it's called when I say a given? Like the given is that I have an A in English. Do you remember what that's called? Oh, sad. Man, I did a bad job of this. It's called a conditional probability. Hopefully that name sounds familiar. A conditional probability. So do you see the numbers I circled? Are they the same?
No.
No. So these are not independent. That's all I require tomorrow. Work and the statement, they're not independent. Because they do not match. Do you remember what I just wrote here, Pablo, here? Right here? These have to be true. Are they the same numbers? 0.1 equal to 0.25?
No.
They're not. So if it's not the same, they're not independent. Now, let's just put a little context here. This is for fun. You don't have to write this. What's the likelihood I get an A in physics? 10% chance, right? I told you I already have an A in English. Now what's my likelihood of getting an A in physics? Ooh, 25% chance. It went up. Does that make sense? If I tell you a student's grades, and I tell you they have an A in these three classes, what do you think the grades are going to be for the other three classes? Maybe not A's, but probably pretty good if you're telling me three classes are already A's, right? So it went up. All right. We got time for one more. Let's do 12. Yeah, let's do the tree. Because I think 13 you guys should be fine. And 14 is the most recent thing we did, so that should be the most familiar. But 12 we haven't done in a while, so let's do 12 and be done. All right, 12. Time for the tree. And you know tomorrow, when you get to this question, you're going to think, oh, I know it's a tree diagram because I left you so much space. Oh, sad. All right. I said, you'll know it's a tree. Oh, what she said?
No, what you said.
What did I say? What I said is, you'll know it's a tree diagram because I leave you so much space. All right. 70% of teenagers who go to take the written driver's license test have studied for this test. So 0.7, and I put under here, studied. So that means if 70% studied, what percent? 30% didn't. Very good. So I put not study. Just winging it. All right. Of those who study, how many pass?
0.95.
That's a lot. So how many fail?
105.
Of those that do not study,
0.6 pass, 0.4 fail.
Very good. What operation should you always do across the tree diagram? Very good. So let's do some multiplication here. I'm going to write down, you do the multiplication, I'll write down the probabilities. So this is study and pass, or S&P. This is study and fail, my fault. This is not study and pass. And this is not study and fail. Okay? So what's 0.7 times 0.95? Shouldn't be negative, times. 0.665 is correct. What is 0.7 times 0.05? And what is 0.3 times 0.6? Is it 0.18? And then 0.3 times 0.4 is 0.12. Guys, what should you do as a mental check tomorrow? Add them together, and they should get what, Bashir? Should be 1. If it doesn't, go back and check your work. It should be 1. Now that's great. That'll give you a good amount of points for this problem, but we haven't even answered the question yet. The question is, what is the probability that a teenager who passes the test? I'm going to say it again. What is the probability that a teenager who you know passes the test? So that to me is shouting. Sorry, I am shouting. But in my brain I'm shouting. That sure as heck sounds like a given. You told me they passed. What's the likelihood they did not study? So that's what most students tell me, Lexi. They go to the did not study and passed, right? But it says out of those who passed. So there are other students out there I'm looking at. So this formula for conditional is the probability that they passed in the bottom. And then what you said, Lexi, not study and pass, that actually goes in the numerator. So it's 0.18 over, and what of these probabilities, how many are passed? Which ones are passed? They passed the test. The top one and the third one. So the denominator is 0.665 plus 0.18. Whatever that is your answer. I'm not going to get the answer for you. It's on the review answer key, so I'm not worried about that. Let's go ahead and end it for today. If you have any questions tonight, email me. I want you to move the desks back. We have 2 minutes to move the desks back. Please ask me. I'm not going to check after 10. So if you want me to respond, do it before 9. I'm going to sleep.
Outro.
Oh, I can't forget my outro, right? All right, guys, thanks for watching. I know it's a really long one. We were pressed for time, but hopefully you do well tomorrow on the test. And for those people out there that are not in my class anymore, hope you're having a good life. See ya!